Hello friends, myself Mr. Shripad Bhide, Assistant Professor, MCA Department, Modern College of Engineering. Today we will see virtualization in cloud computing. In this topic, we will cover kernel and OS, types of kernels, execution environment of virtual machine, what is virtual and abstraction means, implementation of virtualization, architecture of virtualization, layers and different levels of virtualization, and lastly, hypervisor and its types. So, kernel and operating system. Friends, kernel is the core component of the operating system, but kernel itself is not whole operating system. Few utilities should get attached with kernel to work as OS. You will find the utilities which are shown in given diagram. So utilities with respect to the CPU, central processing unit, for processing files and different things, disk management, memory management, and device management. All these utilities should get attached with the kernel to work as a whole operating system. So, the kernel is like the engine of a car. It can run, but you can't drive it until we add some controls, dashboard, maintenance tools, and networking, that is gear. Together these utilities form the user space that makes the kernel a usable operating system. So utilities are required to manage all processes and tasks, also programming environment which acts as a middleman between user and the operating system kernel. Utilities to manage running, stopping and inspecting processes, debugging tools and installing, updating various softwares. Commands for navigating and manipulating as well as formatting files. Memory and CPU monitoring, also for resource controlling. Then with respect to the networking, basic connectivity and services, that is networking utilities, configuration of devices and various drivers, as well as the account management, and for the booting, system booting, like bootloader, which loads kernel into memory first and then init system which starts services after kernel boots. Now there are basically two modes in operating system, the kernel mode and the user mode. The kernel mode is the CPU can access all hardware and memory directly. This mode is used by the kernel and low-level OS services, can execute any CPU instruction without restriction, and an error in this kernel mode definitely crash the whole operating system. With the help of user mode, we can do programs run with limited access. They can't directly touch hardware or critical memory. Some basic steps are required for the same. Must request hardware access via system calls to the kernel, and a crash here, if happens, only affects the application and not the whole operating system. Now this is the actually communication, how the communication is possible between the user mode and the kernel mode and up to reach to the hardware, that is CPU and disk. A flow is given and it is shown with the help of diagram. So a program in user mode needs the hardware operation. That is, if I want to read a file, then it sends a system call for reading a file, that is request to the kernel. The kernel in the kernel mode carries it out, accessing hardware if needed. The result is returned to the program in user mode, means we can see the required file on our desktop. Basically, there are two types of kernels. One is the monolithic kernel and second one is the microkernel. So monolithic kernel, if the user space and the kernel space, if both are having in the same memory, in this type, both user services and the kernel services are implemented in the same memory space. And due to this, the size of kernel as well as the size of operating system, it's get increased. Due to the same space, that is user space as well as the kernel space, overhead of the context switching get avoided. So the execution of the process will be faster in this type as far as the microkernel is concerned. Now, in this microkernel, the user space and the kernel space are implemented very differently. They having different spaces. User space is different and the kernel space is different. There is no overlapping between them. Due to this, reduces the size of the kernel as well as the size of the operating system too. Communication between applications and services is required via message passing. As user and the kernel space is different, so communication between these two, the message passing is the process. And it is easy to add new services at any time, as two different spaces are given. So if we want to add new service at user level or new service at the kernel level, so definitely it is very much possible, easier than the monolithic. And this monolithic kernel is slow with respect to the microkernel. So this is the block diagram of the monolithic kernel and microkernel. One more kernel gets added, which having the hybrid mode, that is the few properties of the monolithic as well as the few properties of the microkernel. You will find here the different spaces of here the user mode and the kernel mode is working on the same space. Here in this diagram, the user mode is showing differently and the kernel mode is showing differently, and the hybrid mode, that is the microlithic and the monolithic kernels. So this is the execution environment of the virtual machine. So how to create the virtual machine? So here at the base level, our physical machine is there, that is our host machine, on which we have installed our basic operating system. So here the basic Windows operating system is installed, and via this operating system we have installed a virtual machine, that is, suppose VMware is the software through which we can create the virtual machines. So on our hardware, that is on our PC, we have installed first operating system and then a software which can create the virtual machines for us. With the help of this VMware software, here I have created 3 different virtual machines: virtual machine 1, virtual machine 2 and virtual machine 3. No doubt it depends how much virtual machines we can create. It definitely depends on our space and the processing speed. So for the virtual machine 1, I have created or installed the Fedora as an operating system. For virtual machine 2, I have installed the Ubuntu as an operating system, and for virtual machine 3, I have installed Windows as an operating system. So every virtual machine having its own kernel, that is showing in the figure, kernel 1, kernel 2 and kernel 3. So this is the execution environment of the virtual machine. Now actually here in this diagram, the kernel mode and the user mode is showing very differently. Now you can see this total square is our main machine, and this yellow part is showing the kernel mode, and this blue part is showing our user mode. Now in the kernel mode, the virtual machine software, that is in the kernel mode, our physical operating system is get installed, and with the help of the operating system, I have installed the software which can create virtual machines for me. So this is the VMware software which is installed on the kernel mode. Now our basic hardware, as I told, the kernel mode and the user mode. So on my PC, these 2 modes are there, and the virtual machines that I am creating, they gets created in the user mode of my basic machine. So in my user mode, the virtual machine, I have created the virtual machine 1, the virtual machine 2 and the virtual machine 3. So as the virtual machine 1 having its separate OS, virtual machine 2 also having the separate OS, virtual machine 3 also having the separate OS. So as I told OS, so the OS having again 2 modes, that is the kernel mode and the user mode. But as far as the virtual machine is concerned, the kernel mode of the virtual machine is treated as a virtual kernel mode of the machine 1 and virtual user mode of the machine 1, virtual kernel mode of the machine 2 and the virtual user mode of the machine 2, and this is the virtual kernel mode of the machine 3 and a virtual user mode of the machine 3. So on my basic PC, with the help of the VMware or any virtual machine software, I have created 3 virtual machines on my user mode, that is virtual 1, virtual machine 2 and virtual machine 3. And these virtual machines having different OS, and whenever I say OS, the OS should have the 2 modes, that is the kernel mode and the user mode. As these 3 machines are the virtual, so these modes are also known as virtual kernel mode 1, virtual user mode 1, virtual kernel mode 2, virtual user mode 2, virtual kernel mode 3 and the virtual user mode 3. So this is our traditional architecture, and if the virtual architecture is created, how it looks like. So here you can easily see that the 3 operating systems are installed on the same machine by using the same machine, single machine, with the help of the virtualization layer, that is the hypervisor in as far as the cloud is concerned, or the VMware software if our PC is concerned. So I have created 3 different operating systems or 3 different partitions for using different operating systems. And here our traditional mode or traditional architecture where the single operating system is there and all the applications are gets installed on my single operating system. So what is the keyword virtual means? So number of times you have uttered the keyword virtual in object-oriented programming also. Sometimes something that behaves like or appear to be a physical thing but is actually created or simulated by software. It is not exist in reality, but it is working there. A virtual object in computing is like an illusion in a magic show. You can interact with it as if it's real, but behind the scenes something else is doing the work. Not physically present, but functions as if it were. So this is nothing but the virtual. So if it is often used to save resources, add flexibility, or allow multiple things to share the same hardware. Example of this, we can create virtual memory. So use part of a hard drive to act like extra RAM. So guys, you all are knowing that whenever the processor wants to execute any program, that program should present in our RAM. But due to the minimization in space, if the few part of the hard disk, that is the secondary memory, is used as a primary memory for time being, so that secondary memory part is treated as or working as a virtual memory. So virtual machine software that runs an entire fake computer inside another, like VMware or VirtualBox, we can create the virtual machines. Virtual network, software defined networks that behaves like physical ones but have no dedicated cables. And virtual storage, cloud storage that appears like a local drive. Though we are working on the storage devices provided by the cloud, but it seems that we are working on our local drives. So this is nothing but the virtual. So one more keyword you should know, that is called the abstraction. So abstraction is the concept of hiding unnecessary details and showing only the important or relevant parts of something. So it's easier to understand and work with. Abstraction is used to manage complexity by providing a simplified interface to more complicated underlying systems. The user doesn't need to know how everything works internally, just how to use it. Only to know how to use it. So what are the libraries? So libraries sit between the application and the OS, providing functions the application call. So in this diagram you can see the library level. So the libraries are between the application and the system, and the API hooks, via the API hooks the libraries are working. So API hooks controls communication between applications and the system. Now the virtualization in cloud. It is used for creation of virtual versions of services. Due to this, multiple operating systems and applications can run, as we have seen already, on the same machine, its same hardware at the same time. It is very much important. Same machine, same hardware, and at the same time. It increases the utilization and flexibility of hardware. It is very much cost effective, hardware reducing and energy saving techniques used by the cloud providers. It allows sharing of single physical instance of a resource or an application among multiple customers and organizations at one time. It does this by assigning a logical name to physical storage and providing a pointer to that physical resource on demand. As you know, guys, the after creation of the virtual machine, that particular machine is not exist in reality. So the logical name is given for this particular virtual machine, and as per the requirement, the pointer is created whenever it is very much needed. So it is often synonymous for hardware virtualization, that is called the infrastructure as a service. It also provides a virtual environment for applications as well as storage, memory and networking too. So this is the architecture of the virtualization like our virtual machine. So server hardware, that is our host machine. On the host machine we have installed the operating system, that is host operating system. After the host operating system we have installed the hypervisor. Via we are creating the virtualization in our cloud, and with the help of the hypervisor, here we are creating the guest machine 1, guest machine 2 and guest machine 3. So guest machine may have the as per requirement operating system 1, as per requirement operating system 2 on guest machine 2, and as per requirement operating system 3 on the guest machine 3, and all these guest machines can working independently without interacting with each other. But as a control, the host operating system is there. So host machine is nothing but on which the virtual machine is going to be built, and guest machine, that is the virtual machine, is referred as a guest machine. Here we have created 3 guest machine on a single host machine. So what are the levels of virtualization in cloud computing? So it is not so simple to set up virtualization in cloud computing. Suppose computer A is running on the Unix operating system, and this particular machine gets configured on some particular hardware. So some particular hardware is configured with this Unix operating system. By using same hardware, now in virtualization we are using the same hardware. So by using the same hardware but a different operating system, it is not so feasible or easy task, as working culture of every hardware and every operating system is very much different. So communication between hardware and software, or hardware and the operating system, for good communication, the configuration is very much required. And if one hardware is configured with the operating system 1, then it may get difficult to configure the same hardware for the different operating system, and this is possible in virtualization. Use of the hypervisor makes it easy. So what is hypervisor? It is a software layer and nothing but it is a bunch of programs which is a bridge between the hardware and the virtual operating system, which allows smooth functioning. Now here in cloud computing, the 5 levels are used for implementation of virtualization. These levels are instruction set architecture level, which uses emulation. So what is emulation? Emulation is when one system imits another system so that programs or data designed for the original system can run on the new one. That just we have seen that if we want to configure one hardware with the another OS, but that hardware is already configured with the any different OS. So with the help of this instruction set architecture, it is virtualization, it is very much possible. So hardware abstraction level, which uses hypervisor to visualize hardware component and allow multiple users to use the same hardware simultaneously. Operating system level virtualization, which creates an isolated container on the physical server that functions like a virtual server. So with the help of the same server, we can take or we can use a different OS by using the same server. Library level, which uses API hooks to control communication between applications and the systems. And lastly, the application level, which visualizes only a single application rather than the entire platform. So here the layers of the virtualization, how the virtualization is possible. First, the storage virtualization. Then for accessing it, the networking virtualization is there. Now for processing all these things, the processing virtualization is there. We can process all these things, we can work all these things via any application. So application virtualization is there. And lastly, as we are accessing information, so lastly it is the access virtualization is there. Now, as I told, the virtualization in cloud computing is possible with the help of the hypervisor, which is the layer of software. There are basically two types of hypervisors, type 1 hypervisor and type 2 hypervisor. So in the type 1 hypervisor, on our host operating system, the hypervisor is not get installed, but hypervisor along with its functionality, it work as a operating system too. So you will find in this diagram the hardware, and immediately the hypervisor is installed without any operating system. So hypervisor will also work as an operating system. But if you see the type 2 hypervisor, here on our hardware, the host OS is installed, and with the help of host OS, we have installed the hypervisor, and then the virtual machines are created. So this is the basic difference between the type 1 hypervisor and the type 2 hypervisor. So type 1 is bare metal hypervisor and type 2 is hosted embedded hypervisor. So in type 1 hypervisor, it functions as a light OS, as I told, or you have already seen in the figure. Here no operating system is separately installed, so hypervisor is work as a light OS. It directly operates on host hardware or interacts directly. It is present on the top of the bare metal server, so client has complete access to the hardware. It is installed directly on the host machine's physical hardware, not through any OS. In some cases, a type 1 hypervisor is embedded in the machine's firmware. So what is firmware? Firmware is a software program embedded into hardware device so that device function very smoothly and effectively. So this negotiates directly with server hardware to allocate dedicated resource to virtual machine, and it can also flexibly share resources depending on various virtual machine requests. So type 2 hypervisor is functions as a software layer, presents on top of OS, as the separate OS is provided here, and on OS we are installing the type 2 hypervisor. So on OS, the hypervisor or the type 2 hypervisor is there, most often used in desktop and development environments. Workloads are not as resource intensive or critical to operations, interacts with the underlying host machine hardware through the host machine's operating system. So you will find the difference between the two hypervisors here. This is the type 1 hypervisor. You will find here, this is the type 1 hypervisor, that is called the bare metal. So hypervisor, there is no different OS is there. So hypervisor also work as a light OS, and directly here the two virtual machines are created. And here in the type 2 hypervisor, on our server, the specific OS is installed. After installation of OS, the hypervisor is installed, and hypervisor installation, we can create the different virtual machines. So these machines are treated as a guest machines, and this server is nothing but our host machine or the server. So this is the type 1 hypervisor, and this is the type 2 hypervisor. So this is the basic difference between the type 1 hypervisor and the type 2 hypervisor. So as we have already seen, so physical host machine hardware which runs on this, and this runs on the host operating system. So where actually the type 1 hypervisor is useful. So various data centers or servers where high performance, low latency and the large scale virtualization is required, the type 1 hypervisor is used, and type 2 hypervisor for the testing and development purpose on our desktop, laptops, running different OS for experiment purpose, we can use this type 2 hypervisor on our personal computers. So these are the different softwares given via which we can create the type 1 hypervisor. So Microsoft Hyper 5, KVM, these are the VMware EXXI, these are the type 1 hypervisor examples via we can create the hypervisor. And here are the type 2 hypervisors. So Oracle VM VirtualBox, VMware Workstation, Microsoft Virtual PC, these are the type 2 hypervisors. To know the hypervisor or to working with the type 2 hypervisor, the basic knowledge is very much required, but where the OS is absent in type 1, the administrator knowledge or administrator level knowledge is very much required for the using type 1 hypervisor. So low latency means the delay between the server and the user or the workstation, where we are requesting for the server any service. So the delay between the server and the end user. Now we can implement these type of virtualizations in cloud, the hardware virtualization, that is also the storage virtualization or desktop virtualization, the software virtualization also there, the network virtualization is also there, and application level virtualization is also there. So we can see all these virtualizations in coming videos. Thank you very much. Have a nice day.